Transient thermal simulations are an essential tool for heat exchanger structural and thermal analysis. These simulations are indispensable due to the high influence of thermal gradients from transient operating cycles and extremely heavy thermal shocks that cause overall mechanical damages in critical areas, such as the tube bundle, tube plates, welded joints, inlet and outlet nozzles, and heads. Here, the temperature evolution of the tube sheet and front head area is shown along the operating cycle of a heat exchanger. In this example, the inlet fluid produces a thermal shock that can originate high thermal gradients of about 160 degrees Celsius between the tube side and the shell side. This is translated into areas of high stress concentration at the tubes, and the consequence is the appearance of small cracks. For this type of simulations, a data life cycle becomes necessary to implement relevant information on its finite element model, such as bulk temperatures and convective heat transfer coefficients in different areas of the heat exchanger. At Cade, our mechanical engineers and simulation experts work hand in hand with our process engineers in order to perform heat exchanger analysis in the most realistic way possible. Therefore, we're able to detect failure modes that usually can't be detected through conventional analysis, and as a result, operating processes can be improved and optimized.